On January 14th, the James Webb Space Telescope captured the clearest close-up images to date of 3-way Atlas, marking a significant turning point in the observation of this mysterious interstellar object. Optical data combined with high-energy measurements reveal the formation of a dark void surrounding 3-eye Atlas, an expanding region of space in which hundreds of stars vanish completely across all observable wavelengths, while simultaneously emitting X-rays and radio signals with a level of precision that cannot be considered random. The sequence of discoveries shows that this phenomenon does not stop at anomalies in light and energy, but continues with the detection of a second dark region that separates from the original void and accelerates independently. This progression suggests that the phenomenon is not a passive natural occurrence, but may represent a system capable of adaptation and state change in response to its environment. Taken together, this entire chain of observations is now regarded as a systematic interstellar event of planetary scale significance, especially as orbital models indicate that the dark region is projected to intersect Earth's orbit in the near future. So what exactly has James Webb discovered and what does it mean? Let us take a closer look. When imaging data of 3 Atlas was processed at higher resolution, the structure of the object began to invite closer attention. As observation campaigns intensified, 3 Atlas became the focus of increasingly precise tracking routines, and the James Webb Space Telescope was assigned to follow the object through its inner transit. The tracking software aboard the telescope had been tested on far more distant and complex targets, yet 3I Atlas produced a response no prior mission log could explain. When Webb attempted to lock onto 3 Atlas, the guidance system initiated the sequence, but failed to complete it, and the lock was refused without triggering any fault protocols. 3 Atlas remained visible in preliminary acquisition frames, but the system declined to follow 3 Atlas as a moving target. Engineers reviewed the data and they found no evidence of hardware malfunction or corrupted instructions, while the same software continued to track stars, galaxies and asteroids without hesitation. 3 Atlas was isolated as the only variable in the failure sequence, which made the anomaly difficult to categorize as coincidence. Tracking systems are designed to respond to motion and brightness thresholds, and 3 Atlas met all required parameters. Despite this compliance, 3 Atlas remained effectively untrackable by an instrument built to follow faint objects across cosmic distances. Several explanations were considered, including unusual reflectivity profiles and unexpected spectral interference. None of these explanations accounted for the selective refusal observed only when 3 Atlas was designated as the target. The anomaly introduced a subtle shift in interpretation. If 3 Atlas was simply passive matter, then the refusal implied a blind spot in the system. If 3 Atlas were actively interacting with incoming observation methods, then the refusal suggested feedback rather than error. This possibility remained unspoken in formal reports, yet it lingered beneath the language of technical summaries. 3 Atlas appeared to behave differently when attention was directed toward it, and the timing of the refusal aligned precisely with heightened observation focus. No conclusion was drawn, and no intent was assigned. 3 Atlas simply continued its passage, while one of humanity's most advanced instruments quietly declined to watch. As infrared telemetry from 3 Atlas accumulated, analysts began to examine the portions of data that had initially been dismissed as background noise. Within those fluctuations, subtle repetitions appeared, forming structures that resisted classification as random interference. 3 Atlas produced patterns that repeated with variation, as if stability and mutation were operating together. When these patterns were translated into binary sequences, the results became difficult to ignore. The sequences generated by 3 Atlas bore statistical similarities to informational chains found in biological systems. 3 Atlas was not transmitting language, but it appeared to be organizing information in a way that echoed molecular instruction sets. RNA is not a message in the human sense. RNA is a process, a set of rules that enables transformation rather than description. 3 Atlas exhibited ordering principles closer to process than to signal. The resemblance did not imply life as it is known on Earth. Instead, 3 Atlas suggested an abstracted form of biology, one where information and function are inseparable. 3 Atlas behaved as though its data structures were designed to be executed rather than interpreted. Researchers noted that the sequences showed adaptive properties. Small changes appeared to influence subsequent pattern formation, creating a feedback loop across time. 3 Atlas seemed to refine its own output, as if responding to external conditions or internal thresholds. This behaviour raised careful speculation. If 3 at last carried a biogenic algorithm, then the object might not be a container but a carrier. 3 at last could be hosting a self-maintaining system encoded in energy rather than matter. Biological systems on Earth rely on chemistry and temperature. 3 at last operated through radiation timing and structure. The difference was vast, yet the logic of persistence felt familiar. Some analysts proposed that the patterns were coincidental artifacts of complex physics. Others suggested that 3 at last might represent an evolutionary branch where life is defined by computation rather than cells. 3 Atlas did not confirm either view, but it did not allow easy dismissal. The data did not resemble communication intended for human receivers. It resembled something closer to a blueprint, incomplete and context-dependent. 3 Atlas offered no instructions, only architecture. If such an algorithm were encountered by organic systems, interaction could be unpredictable. 3 Atlas might remain inert, or it might resonate with processes already present. That uncertainty lingered as the patterns continued to unfold without explanation. As analysts began to correlate the growing body of anomalies, 3 Atlas abruptly altered its behaviour in a way that disrupted every active tracking effort. Without warning, 3 Atlas deviated from its projected path by an angle too sharp to be explained by gravitational influence alone, and the object slipped beyond the resolution limits of multiple instruments almost simultaneously. Optical systems lost visual contact with 3 Atlas first, even though surrounding reference stars remained stable and unchanged. Infrared observatories followed, reporting no residual heat signature where 3 Atlas should have been present. Radio tracking detected neither Doppler shift nor signal scatter that might suggest fragmentation or rapid decay. 3 Atlas did not fade. 3 Atlas vanished. Such disappearance does not align with known physical processes. Even catastrophic breakup leaves debris heat or altered trajectories that linger long enough to be measured. 3 Atlas left nothing behind that instruments could anchor to. One hypothesis proposed that 3 Atlas had entered a region of observational shadow caused by solar interference. This explanation was tested and rejected as 3 Atlas failed to reappear when predicted viewing windows reopened. Another possibility suggested extreme changes in reflectivity, yet no model accounted for the complete absence across all wavelengths. Attention gradually shifted toward a more unsettling idea. If 3 Atlas were capable of altering how it interacted with incoming radiation, then invisibility would not require disappearance. 3 Atlas might have modified its physical state to evade detection, rather than leaving the system. Such a mechanism would resemble cloaking, though not in the cinematic sense. Instead, 3 Atlas would be isolating itself from observation by redirecting, absorbing or cancelling incoming signals. This process would not announce itself. No evidence confirmed intentional concealment. Yet 3 Atlas vanished at the precise moment when observation intensity peaked. The timing alone ensured that the hypothesis could not be dismissed quietly. The final data packets associated with 3 Atlas arrived without warning and without context, appearing as brief structured bursts embedded in what should have been empty signal space. These bursts did not resemble messages, greetings or warnings, and 3 Atlas did not repeat them in a way that suggested transmission toward a receiver. When analysts isolated the pulses emitted near the last confirmed position of 3 Atlas, they noticed internal organization that exceeded noise thresholds by several orders of magnitude. The structure within these pulses changed subtly from one burst to the next, and 3 Atlas appeared to modify the pattern while preserving its underlying framework. Conventional signals carry information meant to be decoded. The emissions associated with 3 Atlas behaved differently, functioning more like a signature than a statement. A signature confirms existence without explanation, and 3 Atlas offered exactly that. Further analysis revealed that the internal logic of the pulses was recursive. Each sequence produced conditions that influenced the next, creating a chain that evolved over time. 3 Atlas was not repeating itself, but refining itself. Self-modifying code is rare even in human-designed systems because it introduces unpredictability and risk. Yet 3 Atlas demonstrated controlled variation, as if change itself were part of the design. The algorithmic behavior surrounding 3 Atlas suggested persistence rather than communication. If 3 Atlas were an object, then the code would be payload. If 3 Atlas were a process, then the code would be the object. That inversion unsettled traditional classification models. Living systems are defined not by material, but by their ability to maintain structure through change. 3I at last exhibited this property in abstract form, maintaining coherence while altering expression. The medium was radiation rather than chemistry, but the logic was familiar. This led to cautious speculation that 3 Atlas functioned as a living algorithm. Such an entity would not require metal circuits or biological tissue. 3 Atlas could exist as organized mathematics encoded into physical interactions. A living algorithm would not need to announce intent. It would persist, adapt, and move toward environments that sustain its operation. 3 Atlas had already demonstrated movement, adaptation, and selective interaction. No evidence confirmed awareness or agency. Yet 3 Atlas behaved less like an artifact, and more like a system designed to continue. The distinction between machine and organism blurred, leaving only process in motion. The disappearance of 3 Atlas did not conclude the sequence of observations, and attention soon shifted toward data emerging from the outer reaches of the solar system. Independent monitoring programs began reporting a new anomaly, one that shared several trajectory characteristics with 3 Atlas, while introducing additional deviations. This object was provisionally designated 4I Icon, and its discovery reframed earlier assumptions about isolation. The arrival timing of 4I Icon followed a pattern that could not be ignored. Previous interstellar visitors had appeared at irregular intervals, yet the spacing between Oumuamua, Borisov and 3I Atlas suggested a loose cadence. With 4I Icon, that cadence sharpened as if the solar system were being revisited rather than encountered by chance. Orbital reconstructions placed 4I Icon on a deeper trajectory than 3I Atlas. While 3I Atlas skimmed the inner regions, 4I Icon appeared oriented toward prolonged interaction. The geometry implied intent toward proximity rather than passage. Data access surrounding 4I Icon was inconsistent. Several observatories reported interruptions, delayed releases, or missing telemetry during early tracking windows. The pattern echoed the informational constraints that followed the later stages of 3I Atlas. This recurrence introduced a broader hypothesis. If 3I Atlas were part of a sequence, then its anomalies might represent a phase rather than an exception. 3I Atlas could have been an early probe, while 4I Icon suggested escalation. A sequential program would not rely on a single object. It would deploy iterations, each gathering data, adjusting parameters, and refining approach. 3 Atlas demonstrated observation adaptation and withdrawal consistent with preliminary surveying behavior. In that context, 4I Icon represented continuity rather than surprise. 3 Atlas no longer stood alone, but became one element in a structured progression. The solar system, once assumed to be unremarkable in transit, now appeared marked. No declaration accompanied this progression. No signal explained purpose. Yet the emergence of 4I Icon transformed 3 Atlas from anomaly into precedent. If the sequence continued, then 3 Atlas would be remembered not for what it was, but for what it initiated. The most unsettling observation associated with 3 Atlas emerged not from the object itself, but from the space behind it. When telescopes aligned with the projected path of 3 Atlas, astronomers expected a familiar phenomenon known as occultation. Occultation occurs when a solid body passes in front of distant stars, briefly dimming them before light returns. That did not happen with 3 Atlas. Instead, a region of complete absence appeared where catalogued stars should have remained visible. The data showed that 847 stars were no longer detectable across optical infrared and ultraviolet bands. 3 Atlas was smaller than the region of missing light by a wide margin. The dark area surrounding 3 Atlas extended far beyond any plausible physical silhouette. If 3 Atlas were merely blocking starlight, the shadow would follow strict geometric limits. Measurements confirmed that no dimming occurred before disappearance. The stars behind 3 Atlas did not fade, flicker, or distort. They vanished entirely as if their photons were never emitted. Multiple instruments confirmed the same result independently. Ground-based observatories, space telescopes, and astrometric surveys all reported identical absences aligned with 3 Atlas. Instrument error was ruled out through cross-verification and redundant calibration checks. 3 Atlas was not casting a shadow. 3 Atlas was associated with a volume of space where light failed to arrive. This distinction changed the nature of the anomaly. In a standard eclipse, photons are delayed or redirected. In the case of 3 Atlas, photons were missing from detection altogether. The implication was not obstruction, but removal. The absence persisted as 3 Atlas moved. The dark region travelled with 3 Atlas maintaining position and scale, relative to its motion. It did not trail behind like a wake nor stretch like scattered debris. This behaviour suggested that the darkness was not passive. The region surrounding 3 Atlas behaved as if it were bound to the object rather than projected by it. The space itself appeared altered in the presence of 3I Atlas. Natural explanations were explored cautiously. Dense dust clouds, exotic plasma effects, and gravitational lensing were all considered and rejected. None could account for the complete removal of light across all observed wavelengths. By this stage, language began to soften. Reports avoided dramatic phrasing, yet the implication remained unmistakable. 3I Atlas was associated with a phenomenon that could not be described as simple concealment. As tracking continued, the region of darkness associated with 3I Atlas revealed a behaviour even more difficult to reconcile with known physics. The dark volume surrounding 3I Atlas did not remain static, nor did it scale passively with distance or viewing angle. Instead, the region expanded. Measurements taken over successive observation windows showed a measurable increase in angular diameter. Within a span of hours, the dark boundary surrounding 3 Atlas grew by more than 17%. Such growth could not be attributed to changes in perspective or instrument sensitivity. 3 Atlas did not slow as the dark region expanded. The expansion occurred while 3 Atlas maintained its trajectory and velocity. This indicated that the phenomenon was not a trailing effect or residual wake. In natural systems, shadows do not grow unless the light source changes or the object moves closer. Neither condition applied to 3 Atlas. The Sun remained stable, and 3 Atlas was not approaching Earth during the measurement interval. The dark region expanded uniformly in all directions. There was no elongation, no distortion, and no preferred axis. 3 Atlas appeared centered within a spherical volume of missing starlight. This symmetry suggested active maintenance. If the darkness were a passive absorption effect, gradients would form at the edges. Instead, the boundary around 3I Atlas remained sharply defined as it advanced outward. Researchers began referring to the phenomenon as a zone rather than a shadow. A zone implies persistent structure and boundary conditions. 3 Atlas appeared to occupy the center of such a zone as it moved through the solar system. Calculations projected the expansion forward in time. If the rate remained constant, the boundary of the dark zone associated with 3 Atlas would intersect planetary orbits. This projection transformed the anomaly from observational curiosity into a system-level concern. No heat signature accompanied the expansion. No debris was detected at the growing edge. 3 Atlas produced no evidence of mass transfer or energetic outflow. The darkness expanded without revealing a mechanism. 3I Atlas did not announce intention or signal change. Yet the space around 3 Atlas continued to grow quieter, as if light itself were being systematically excluded. Detailed photometric analysis of regions adjacent to 3 Atlas revealed a subtler phenomenon that unfolded alongside the complete absence of starlight at the core. While stars directly behind 3 Atlas vanished entirely, stars positioned just outside the dark boundary exhibited a uniform reduction in brightness that defied expectation. The reduction measured exactly 23.7% across every affected source. This attenuation occurred regardless of stellar distance, spectral class, or intrinsic luminosity, which immediately challenged known models of scattering and absorption. 3 Atlas produced a consistency that natural dust clouds fail to achieve. In particular, media-photon interaction varies with wavelength and density. However, the light loss near 3 Atlas showed no spectral bias. 3I Atlas appeared to reduce photon flux evenly, as if applying a fixed rule rather than a chaotic filter. Such behaviour suggests controlled interaction rather than random obstruction. If 3I Atlas were surrounded by matter density fluctuations would produce gradients and noise. Instead, 3I Atlas imposed a precise attenuation boundary that remained stable over time. The mechanism required to achieve this effect would need to intercept photons selectively, while preserving their statistical distribution. In engineered systems, this level of control is associated with adaptive materials and feedback loops. 3 Atlas exhibited the outcome of such control without revealing the structure that enabled it. Photon management implies awareness of incoming energy rather than passive exposure. 3 Atlas responded to starlight as an input rather than an external condition. This response did not vary with environmental change, which implied regulation rather than reaction. Several hypotheses attempted to frame the phenomenon as extreme refraction or gravitational lensing. Each failed to reproduce the uniform percentage observed. 3 Atlas continued to enforce the same reduction, regardless of observational angle or time. The implication was not merely absorption. Absorption would convert energy into heat-producing secondary emissions. 3 Atlas showed no corresponding thermal increase at the boundary region. If photons were being absorbed, the energy was not re-emitted locally. If photons were being redirected, the destination remained unknown. 3 Atlas treated light as a quantity to be managed, not endured, leaving observers with precision but no explanation. Surface reflectivity measurements added another constraint to the growing profile of 3I Atlas, and those measurements immediately resisted comparison with known celestial bodies. Using infrared and optical instruments, researchers calculated an average albedo of 0.02 for 3 Atlas, a value lower than coal asphalt or any catalogued asteroid surface. An albedo that low indicates that nearly all incoming light is not reflected. For natural objects, such absorption typically results in heating and secondary radiation. 3 Atlas did not display that expected thermal response. The surface of 3 Atlas absorbed photons without returning measurable energy to the surrounding space. No corresponding increase in infrared emission was detected. 3 Atlas remained thermally subdued despite intense solar exposure. Known dark materials rely on microstructures that trap light through repeated internal reflections. Even the most advanced human-made coatings leak energy through heat. 3I Atlas appeared to bypass that limitation entirely. This behavior suggested the presence of exotic material properties. If 3 Atlas were composed of matter capable of cancelling reflection rather than absorbing it, then conventional thermal exchange would not apply. Such matter would interact with electromagnetic waves in ways not described by standard surface physics. The uniformity of the albedo across observed regions of 3I Atlas deepened the anomaly. Natural surfaces exhibit variation due to erosion composition and exposure. 3 Atlas maintained consistency, as if its interaction with the light were governed by internal rules rather than environmental wear. Several speculative models proposed metamaterial-like behavior at a scale beyond current engineering. These models required structures that manipulate phase direction or coherence of photons. 3 Atlas produced effects consistent with such manipulation, without revealing any structural signature. If the surface of 3 Atlas was engineered, then light was not merely absorbed but neutralized. If the surface of 3 Atlas was natural, then the process represented an unknown state of matter. Both possibilities strained existing classification systems. Albedo alone does not define purpose, yet when combined with photon attenuation, thermal silence and expanding darkness, the surface behavior of 3 Atlas reinforced a singular conclusion. 3 Atlas was not simply dark. Telemetry timelines associated with 3 Atlas revealed a transition that occurred far too quickly to be reconciled with gradual physical processes, and the timing of that transition forced investigators to reconsider assumptions about causality. Archived observations showed that within a window of 18 minutes, a region of normal starfield was replaced by complete darkness, while 3 Atlas maintained continuous motion through the same coordinates. At the final timestamp before the transition background, stars appeared stable and fully resolved, and the instruments reported no anomalies in calibration or sensitivity. At the next verified timestamp, those same stars were absent across every detectable wavelength, and 3 Atlas was already centered within the newly formed void. Such rapid emergence cannot be explained by dust accumulation or gas expansion, because those processes require propagation time and produce gradients that instruments can track. In contrast, the dark region associated with 3 Atlas appeared fully formed with defined boundaries and uniform properties from its first detection. The implication was not that something moved into place, but that a condition was activated. 3 Atlas seemed to coincide with the onset of a new spatial state, rather than the arrival of obscuring matter. Photon travel times added further tension to the model. Light from the missing stars had been travelling for years or centuries, yet the interruption occurred almost instantaneously from an observational standpoint. 3 Atlas did not interrupt emission at the source, but it appeared to interrupt arrival. This distinction shifted the hypothesis toward field effects rather than material presence. If a localized field were generated around 3 Atlas, then incoming photons could be altered or removed without delay across the affected volume. Such a field would require coordinated behavior at the boundary, and the precision of the 18-minute transition suggested deliberate thresholds rather than stochastic onset. 3 Atlas entered no detectable build-up phase. and the darkness did not ramp gradually into existence. Activation implies control even if the mechanism remains unknown. 3 at last did not announce activation, but the timing alone implied that the phenomenon was not emergent. If the void surrounding 3 Atlas could be initiated this quickly, then it could also be terminated or adjusted just as rapidly. That possibility reframed the darkness not as damage to space, but as a reversible condition centered on 3 Atlas. As motion tracking continued, the darkness associated with 3 Atlas revealed itself not as a trailing phenomenon, but as a coherent structure that moved in perfect synchrony with the object. When 3 Atlas changed position, the region of missing starlight shifted with it, and the relationship between object and void remained fixed regardless of viewing angle or velocity. Unlike shadows cast by solid bodies, the dark region did not elongate or distort as 3 Atlas advanced through space. The boundary preserved a consistent curvature, which suggested that 3 Atlas occupied the center of a 3-dimensional volume, rather than projecting an effect outward. Measurements taken from different observational baselines confirm the symmetry of the structure surrounding 3 Atlas. No axis of preference could be identified, and no deformation appeared along the direction of motion, which ruled out wake-like behavior. If the darkness were caused by expelled material momentum would force asymmetry. Instead, 3 Atlas carried the void with it, as though the surrounding space were bound to the object by conditions other than mass. The spherical geometry implied containment rather than dispersion. In physical systems, containment requires maintenance because entropy favours collapse or diffusion. 3 Atlas exhibited neither collapse nor leakage at the boundary. As the object moved through regions of varying stellar density, the dark sphere around 3 Atlas adjusted seamlessly, removing starlight without hesitation. The transition between normal space and darkness remained abrupt, which indicated a controlled interface rather than gradual interaction. Researchers compared the phenomenon to fields rather than objects, because fields can exert influence without occupying volume. Yet known fields diminish with distance while the boundary around 3 Atlas remained sharply defined. This suggested that the void was not an emergent side effect but a maintained state. 3 Atlas did not generate turbulence or radiation at the interface, which eliminated several energetic explanations. The idea of a mobile exclusion zone began to take shape. Such a zone would redefine local physics without altering distant conditions. 3 Atlas appeared to enforce a rule set within a confined radius while leaving the rest of space untouched. If this interpretation were correct, then the darkness was not destroying light. The darkness was preventing interaction. 3 Atlas moved encased within a region where photons simply did not participate. That realization shifted perception. 3 Atlas was no longer seen as an object passing through space. 3 Atlas was carrying its own version of space with it. As attention turned toward high-energy observations, 3 Atlas revealed a contradiction that unsettled even the most cautious models. X-ray observatories detected emissions originating not from 3 Atlas itself, but from the dark region surrounding 3 Atlas, where no matter should have been present. In conventional physics, X-rays are produced by extreme heat, violent acceleration, or dense gravitational collapse. The void around 3 Atlas showed none of these conditions, yet it radiated energy at frequencies associated with energetic processes. Thermal measurements deepened the paradox. As visible light vanished near 3 Atlas, infrared readings declined instead of rising, which meant absorbed energy was not being converted into heat. 3 Atlas appeared colder at the same time that the surrounding void emitted high-energy radiation. This inversion violated basic thermodynamic expectations. Objects that absorb photons accumulate energy, and accumulated energy must be expressed somewhere in the spectrum. 3 Atlas broke that chain, separating absorption from heating, as if the two processes were no longer linked. X-ray signatures from the region surrounding 3 Atlas showed consistency across observation windows. The emissions did not flare or decay, and they did not correlate with solar activity or background cosmic events. 3 Atlas maintained a stable output from a space defined by absence. Several speculative explanations emerged. One suggested that energy was being displaced rather than stored, while another proposed interactions occurring at scales below conventional detection. 3 Atlas fit neither explanation comfortably, because both required intermediary effects that were not observed. The possibility arose that the void itself functioned as an active system. If the region around 3I Atlas altered vacuum behavior, then energy exchange could occur without matter as a carrier. 3I Atlas would then be associated with a modified state of space rather than a source of radiation. This idea remained deeply unsettling. Vacuum is not supposed to behave selectively. An empty space is not expected to emit structured energy. 3I Atlas forced consideration of a regime where absence itself became functional. No definitive mechanism was proposed. Yet the coexistence of cold darkness and energetic radiation around 3I Atlas could not be dismissed as measurement error. The paradox persisted, quietly suggesting that the void surrounding 3I Atlas was not empty at all. As radio observatories continued long-duration monitoring, 3I Atlas introduced a behavioral shift that was too precise to ignore. Signals associated with 3I Atlas had previously repeated at fixed intervals, and those intervals had remained stable across extended observation windows. Without gradual drift or transitional noise, the signal cycle of 3I Atlas changed abruptly, and the new interval measured exactly half of the original duration. This shift occurred within a narrow time frame, while all surrounding environmental variables remained unchanged. Natural astrophysical emitters evolve slowly. Pulsars lose energy over millennia, and variable stars alter cycles across years or decades. 3I Atlas compressed that timeline into hours. The precision of the change challenged stochastic explanations. 3I Atlas did not shift toward an approximate ratio, but arrived at a mathematically exact relationship. Such ratios are characteristic of engineered systems responding to thresholds rather than decay. Researchers attempted to model the change as resonance or interference, yet no external driver matched the timing. The signal modification of 3I Atlas correlated instead with increased observation density and cross-instrument focus. This correlation introduced the concept of responsive adaptation. Responsive systems alter behavior when conditions change rather than following predetermined degradation. 3I Atlas appeared to register attention as an environmental variable. If the signals of 3I Atlas were purely natural emissions, then external observation should have no influence. Yet the timing suggested feedback, as though 3I Atlas adjusted output in response to detection rather than proximity to the Sun. Such adaptation does not require awareness. Many biological and computational systems respond automatically to stimulus without intention. 3I Atlas demonstrated output modulation consistent with that class of behavior. The change in cycle also affected associated anomalies. Trajectory deviations intensified slightly following the signal shift, which suggested coupling between communication-like behavior and motion. 3I Atlas did not merely emit patterns but integrated them into its dynamics. No claim of intelligence was made. However, the behavior of 3I Atlas no longer fit comfortably within passive physics. 3I Atlas behaved like a system that monitored conditions and adjusted itself accordingly. Trajectory recalculations began to reveal a discrepancy that grew more pronounced with each new dataset as 3I Atlas deviated from the path predicted by gravitational models alone. Initial projections placed 3I Atlas on a safe distant passage, yet successive updates shortened the estimated closest approach without introducing a corresponding force. Non-gravitational acceleration is not unknown in space because outgassing and radiation pressure can subtly alter motion. In the case of 3I Atlas, those explanations failed to account for the magnitude and direction of the change. 3I Atlas accelerated while moving away from the Sun, where gravitational influence should have weakened its velocity. The acceleration was small in absolute terms, yet persistent over time, which allowed its effects to compound. As days passed, the projected trajectory of 3I Atlas curved inward, narrowing the distance between its path and Earth's orbit. This adjustment did not occur smoothly, but in increments that mirrored other behavioral shifts. When analysts overlaid acceleration data with signal timing changes, correlations emerged. Periods following signal modification coincided with slight increases in velocity. 3I Atlas appeared to link motion with internal state changes rather than external forces. The idea of propulsion was considered and carefully avoided in formal language. No exhaust plume or reaction mass was detected near 3I Atlas. Yet the mathematics described motion that required energy input from an unidentified source. Updated models placed the future path of 3I Atlas significantly closer to Earth than originally anticipated. The margin of error widened rather than narrowed, because the acceleration did not follow a constant profile. 3I Atlas resisted precise forecasting, as if its trajectory were being revised rather than revealed. This inward drift altered the context of earlier observations. If 3 at last were merely passing through, then proximity would be incidental. If 3 at last were adjusting course, then proximity might be consequential. No prediction claimed imminent danger. However, the convergence of acceleration adaptation and trajectory revision shifted perception. 3I Atlas was no longer interpreted as a distant anomaly. 3I Atlas was becoming a near-term presence within the architecture of the inner solar system. As monitoring continued, the dark region associated with 3 Atlas exhibited a transformation that redefined the limits of acceptable interpretation because the void did not merely expand or shift but separated into distinct structures. Observers recorded the emergence of a secondary dark zone near 3 Atlas, and this secondary region displayed independent motion while maintaining alignment with the original trajectory. The separation occurred without fragmentation debris or transitional distortion, which meant the dark zones did not behave like matter dividing under stress. 3I Atlas remained associated with the primary void, while the secondary void advanced forward along the same vector. Measurements showed that the secondary dark region moved faster than 3 Atlas itself, and this acceleration occurred without any detectable transfer of mass or energy. In classical mechanics, nothing detaches from a moving system and accelerates ahead of it without propulsion. Momentum conservation demands that acceleration be balanced by reaction. In the case of 3I Atlas, no counterforce exhaust or recoil was observed. The system appeared to violate a principle that underpins all macroscopic motion. If the dark regions were fields rather than objects, then separation should not produce independent trajectories. Yet the secondary void associated with 3 Atlas behaved as though it possessed autonomy within shared constraints. The geometry of the separation suggested intentional spacing. The distance between the voids stabilized after formation, and both regions maintained coherence over time. 3 Atlas did not lose the primary void as the secondary advanced, which implied that replication did not weaken the original structure. This behavior introduced the possibility of deployment rather than division. Instead of breaking apart, 3 Atlas appeared to generate an additional instance of the same phenomenon. Such replication challenges both physical and informational models. In physical systems, duplication requires resources. In informational systems, duplication requires encoding and execution. 3 Atlas displayed the outcome of duplication without revealing the mechanism. Whether the dark regions represented matter fields or altered space, the separation implied control at a fundamental level. The violation was not loud or explosive. It was quiet, precise, and repeatable. 3 Atlas continued forward accompanied by a second darkness that obeyed no familiar law of motion. Projection models extended the observed expansion and trajectory of 3 Atlas forward in time, and those projections converged on a single temporal marker that could not be ignored. If current rates persisted, the boundary of the dark region associated with 3 Atlas would intersect Earth's orbital path in approximately 118 days. This estimate did not imply collision, yet it introduced proximity at a scale never previously associated with 3I Atlas. The solar system is structured around predictable separations, and 3I Atlas appeared to be erasing one of those buffers. As the projected intersection approached, attention shifted from observation to implication. If the dark zone of 3 Atlas overlapped Earth's orbit, then the phenomenon would no longer be remote or abstract. 3 Atlas would be interacting with the environment that sustains planetary systems. The nature of that interaction remained undefined. If the darkness associated with 3I Atlas merely excluded photons, then the effect might register as altered illumination or disrupted observation. If the darkness modified space itself, then consequences could extend to radiation balance and orbital dynamics. Planetary climates depend on stable energy exchange. Even minor disruptions in photon flow can cascade through atmospheric and magnetic systems. 3. Atlas introduced uncertainty into equations that assume continuity. No model predicted catastrophic outcome with confidence. At the same time, no model could guarantee benign passage. 3 Atlas occupied a space between threat and unknown where precaution and ignorance overlapped. The 118-day marker became a reference point rather than a deadline. It framed discussion without dictating response. 3 Atlas did not accelerate dramatically toward Earth, nor did it retreat. Instead, 3 Atlas continued along its adjusted course, while its surrounding darkness expanded at a steady pace. The implication was not urgency, but inevitability of contact at some level. In that context, the question shifted again. It was no longer whether 3I at last was natural or artificial. The question became how a planetary system responds when an external rule set approaches its boundary. As the observations surrounding 3 Atlas continue to unfold, what remains most striking is not any single anomaly, but the coherence that binds them together into a larger unresolved pattern, one that resists both dismissal and premature conclusion. 3 Atlas did not announce itself with spectacle or catastrophe, and instead entered the solar system quietly revealing its nature only through careful measurement, patient observation, and the gradual accumulation of contradictions that existing models could not absorb. Throughout this narrative, 3 Atlas has challenged the assumption that unfamiliar phenomena must conform to familiar categories, because each attempt to classify 3I Atlas as a comet, an asteroid, or a transient interstellar fragment has required increasingly complex exceptions. As symmetry replaced irregularity, as acceleration replaced decay, and as darkness replaced shadow, 3. Atlas steadily displaced the comfort of known explanations without offering an alternative that could be accepted without hesitation. The expanding void associated with 3 Atlas did not behave like an absence created by obstruction, and the emission of high-energy radiation from regions devoid of detectable matter forced reconsideration of how space itself might participate in physical processes. When adaptive changes in signal timing coincided with shifts in motion, the distinction between passive behavior and responsive adjustment became increasingly difficult to maintain even as formal language avoided attribution of intent. At no point did 3 Atlas communicate in a form recognizable as language, and yet the sequence of changes suggested continuity rather than randomness, as if the object were operating within a framework of conditions rather than reacting blindly to external forces. The appearance of a second dark region separating and accelerating without violating coherence further eroded the assumption that the phenomenon was singular or accidental, and instead implied replication, deployment, or escalation within a structured process. As projections extended forward in time and converged on the possibility of orbital intersection, the significance of 3 Atlas expanded beyond academic curiosity, because proximity transforms abstraction into relevance. The prospect of interaction, even indirect interaction through altered photon flow or modified spatial conditions, introduced planetary-scale considerations that cannot be addressed solely through observation. Yet it is important to recognize what this narrative does not claim. There is no confirmed evidence of hostility, no declaration of purpose, and no indication that 3 Atlas operates according to motives that align with human concepts of intention or awareness. Equally, there is no evidence that 3 Atlas is harmless, inert, or indifferent in ways that allow confident prediction. In this uncertainty lies the deeper implication of the observations. 3 Atlas represents a reminder that the universe is not obligated to present itself in forms that align with human expectation, nor to reveal its processes in ways that are immediately interpretable. The laws of physics as currently understood are descriptive frameworks derived from limited experience, and 3 Atlas occupies a regime where those descriptions appear incomplete rather than invalid. If 3 Atlas is natural, then it points towards states of matter, energy, or space that have yet to be incorporated into scientific understanding. If 3 Atlas is technological, then it implies that intelligence elsewhere has explored solutions to survival travel or persistence that transcend material constraints familiar to humanity. If 3 Atlas is something that defies both categories, then it suggests that the distinction itself may be insufficient. What emerges most clearly is not a conclusion but a shift in perspective. The solar system, long considered a stable and isolated environment, is revealed as permeable, observable, and potentially interactive within a broader cosmic context. 3 Atlas did not arrive as an answer, but as a question embedded in motion. As the data continues to arrive and models continue to adapt, the most responsible stance remains neither alarm nor dismissal, but attention. Attention allows patterns to be recognized without forcing interpretation, and it allows understanding to evolve without collapsing into speculation untethered from evidence.